I mean,
you have 9 minutes.
Hello, everyone. My name is Simone. I'm from the the Department of Mechanical and Industrial Engineering in Taltech. And I'm going to present a few things together with Kashif Mahmood, which is my colleague from the same department. So first of all, a few words about the development of smart manufacturing and commerce products laboratory here in the college. So the project focuses on developing a demo center, but also prototyping laboratory using advanced technologies for production of smart products. So it focuses mainly on 3D technologies, meaning 3D scanning, simulation, 3D printing, prototyping, and post-processing. So basically, the investment plan for 2025 focuses on this kind of technologies with purchase of some 3D scanners, portable 3D scanners, 3D printers for fast prototyping, a thermal camera for measuring and monitoring industrial processes, and also a high-speed film camera and circuit board printer, which are related to this 3D focus. And of course, computer stations, which allow the working of these devices. I have a couple of examples. I will go fast and probably just show the videos of implementation of XR technology in the industrial domain with real use cases in a European project. So we developed a couple of interfaces for mainly tablet visualization with the aim of supporting operators in servicing machines and in assembling tasks on the production floor. Using XR, plugging into 5G connectivity, standalone 5G connectivity in the factory, and also product life cycle management software, and of course, like with at least in the beginning, like a user-centric approach. So, okay, the idea is to have like a smart interface to visualize tasks for the operators in 2 domains, like a machine servicing and the construction and assembly of wooden house modules with local companies. So as I said, I will go through quite fast because we have not so much time. The idea is for both companies is, of course, to reduce number of faults, support operators, but also reduce the faults reporting time, number of non-conformances, especially with the production of wooden houses, and also reduce operators training time because the tools can be used also for this purpose. I guess it will start. So this is a first example of the application for the wooden house assembly. So there is a login with the QR code of the operator on the shop floor. There is an overview of the tasks assigned to the operator for the specific assembly, and a visualization in 3D, a dynamic visualization of the part to be assembled, which can be navigated through and zoom, pan, and whatever you want to do. This visualization can also be transferred in augmented reality, and so in real size to see on the floor next to the real object, the virtual object. And there are some assembly steps which visualizes step by step exactly the different tasks that the operator should do for the assembly of the module. This also comes with more information about the quantity of the pieces, the specific element, and there are more information about specifications of any component that needs to be done in the specific processing. So you can see now also floor tracking through the camera of the tablet and the visualization at some point of the component when it gets loaded. So this is a demo we did in the laboratory in Tallinn, but the operators are already tested the application in the factory, and eventually they will start a production line soon for this specific product, using also this next to the, of course, traditional drawings, which are on paper now. So I think I will just show briefly the non-conformance reporting system and page, and then I will go through the other demo. So there is a page to report non-conformances. Yeah, it takes a while. And is it still running? And yes, where it's possible actually to visualize the type of non-conformance. There is also a possibility to record the audio, take pictures, take videos of the specific non-conformance, and send it to the design department in the company to fix the non-conformance. They will get a notification through that. Second, it's an application for servicing of wood production machines. So there is a possibility of visualizing for the operator that might not be an operator from the actual factory or from the actual producers where the machine is in the factory. So the operator just navigates there, goes to the specific place. There is a text-to-speech also support in this application for
checklist. Follow the link to read the overall safety rules. Wear helmet, safety glasses, and high-vis clothes. Turn the safety switches off. Ensure that entering to the area is safe. Inform contact person.
Can I interact with this? No. And also there is a possibility to visualize the machine in 3D, which also gives the specific instruction for the specific part and tasks details to the operator. This is still a demo. We didn't get all the informations yet about the specific servicing. And there is also possibility to visualize the servicing of the specific part in augmented reality next to the part. But I'll give the words to you because I think we are late.
Tere, minu poolt olen Kashif Mahmood, teadur TalTech Mehaanika Tööstustehnika Instituut, aga nüüd on inglise keeles. Okay, as we talk about more about the digital twin, I think Carly already talked about what is digital twin, how does it help, but here I'm going to talk about what is the 3D simulation, how it can be used in the context of digital manufacturing. And actually it's an integral part of the digital manufacturing. So we use the simulation actually to design the smarter solution to predict what can be happen in the future. Let's say if you need to ramp up a new production line or make some changes, implement some automation. So the virtual environment is the one where you can play and analyze and optimize the processes. So it helps to predict the performance, let's say to speed up the design concept and also validate the changes that may be costly or time consuming in the real environment, but it can be done in the virtual environment with less time and less money. And also if there is an investment, then you can analyze not only the time related KPIs, but also the cost related KPIs, like how much I can have the return of investment, when is the break-even point, when I can get, let's say, the money back or have the profit over there. Also, the 3D simulation helps for educational purpose. Also, it can be in the virtual reality that you can train the industry people, or let's say the students can design the process in the virtual environment and learn that how the process are working, maybe do different setups and see that what is the best performance and what is the logical flow and how it can be optimized. I have one first demo is about that how the virtual lab can be built. And okay, I have some simulation going on here. We start with the 2D floor plan, and then we ask the students, okay, what do you think that what could be done? So some students come up with the solution, let's say, to put the 3D printing, deburring process, packing, and assembly. So that is the one possibility that in the virtual environment, how the students can learn different processes and see that what could be improved and play around there. The next one, if I'm okay, there is the industry, let's say, problem that they have too much transportation of the boxes on the factory floor. So idea is to pilot or to implement the AMR, mobile robots, for the production intralogistic, to find out that how much time the mobile robot takes to transport the products or the boxes from one storage area to another, how much we utilizing the mobile robot, and how much boxes we can transfer. So it can be done, let's say, the proof of concept or study before going to the implementation or buying the mobile robot. So this is, I mean, the software we use is called Visual Components. Actually, it's a quite big simulation. I mean, it takes time. I will move to the next one. Okay, the third one or the last demo, it's also about that how you can improve the intra-logistic or the logistics task or transportation task in the virtual environment, and also how you can remove the inventories or reduce the inventories on the production floor. So the idea here to reduce the buffer on the production floor, we don't need it. And so we created two scenarios, as is and to be. As is that with the intermediate buffer that we have a buffer of the pallets over there. And the next one, there we remove the buffer and how we can improve and what improvement we can see. So there was improvement in the throughput a little bit, and also we have reduced the work in process. Let's say we found out the bottlenecks, what are the bottlenecks, and we reduce that bottlenecks, and also that how much workers covering the distance from one place to another if we have the intermediate storage and if we don't have the intermediate storage. Yeah, I think the slides will be available. You can see, but thank you from my side and the Simone, I would say.
Okay, thank you.